All right, let's look at some review problems to help you prepare for your Module 5 test. So number 1, it says, for what values will the rational expression be undefined? There's a slight misprint on your notes. We're going to replace this with x plus 1 over 4x squared minus 7x minus 2. And I'll show you why here in a second. So a rational expression is undefined when the bottom equals 0. So really we're just trying to figure out when is 4x squared minus 7x minus 2 equal to 0, because we don't want that to occur. So the first number in our trinomial is not 1, it's 4, and there is no GCF, so I will multiply the first and the last numbers, which gives me negative 8. So I'm looking for two numbers that multiply to negative 8, add to negative 7, that's negative 8 and positive 1. That's why we had to change this problem, because it would not have factored otherwise. So I can make my box to try to factor this. So I have 4x squared, or whatever method you use to factor is fine. So I'll put 8x here and 1x here. So out of this first row, I have 4x squared and 8x, so I could take a 4x out. Out of x and negative 2, I can just take a 1 out. Out of the first column, I have 4x squared and x, I could take an x out. And then I have negative 8x and negative 2, which I could take a 2 out, and if the first term is negative, I want to take a negative out as well. So this will factor as 4x plus 1 and x minus 2. And I want to know when that equals 0. So now that I have it equal to 0, I'll just take both factors and set it equal to 0. So 4x plus 1 equals 0, x minus 2 equals 0. So I subtracted 1 on both sides. So 4x will equal negative 1. And I'll divide by 4, so x is negative 1/4. Here I'll just simply add 2, so x is 2. So the two values we cannot use in this rational expression would be negative 1/4 or 2. Those would make it undefined. Our second problem deals with trying to simplify the rational expression. Now when we're simplifying the rational expression, if you recall, we got to make sure we factor first. So if I look at the top, I have 2x minus 8. So 2x minus 8, they're both even, so I can take a 2 out of that numerator. So if I take a 2 out, if I take a 2 out of 2x, I'm left with an x. If I take a 2 out of negative 8, I have a negative 4 left. So the numerator will factor as 2 and x minus 4, and no further because x minus 4 has no exponents or anything. Now the bottom has x squared minus 16, which I can factor as x and 4 because the difference is squares. So x minus 4, x plus 4. So whenever you're simplifying, just make sure you factor top and bottom. And then I cancel anything out that's the same, and of course in this case it's the x minus 4. So the only thing left will be 2 on top and x plus 4 on bottom. So this would be my simplified version of that expression. Okay, here's one more that we're going to try to simplify. Same directions as number 2. So I'm going to try to factor the top and bottom. Now the top is just x plus 1, so it really not factor. But the bottom definitely has some things we can factor out. So I'm going to write that kind of over here and kind of do it step by step. Now the first thing I see is I have 3x squared, 12x, and 9. Those all divide by 3, so I can take a greatest common factor out of 3. And the nice thing is when I do that and divide them all by 3, what I'm left with is I'm left with a trinomial who has a leading coefficient of 1. Those are much easier to factor. Because since it has a leading coefficient of 1, 1 times 3 is 3. So I'm really just trying to figure out what two things multiply to 3 but add to 4. Those would of course be 3 and 1. So this denominator is going to have the 3, which we took out, and then our two factors will be x plus 3, x plus 1. So those will go on the denominator here. So we have 3, x plus 3, x plus 1. So we did all this work just to factor this denominator. but then it takes our expression to this. Now, of course, we can cross out x plus 1. Now, interestingly, there's nothing left on top. So there's nothing left on top, we still have to put something, so we'll put a 1 as a placeholder. Now on the bottom we have 3, and we have x plus 3 left. Okay, so on to section 2. Section 2 we talked about multiplying and dividing rational expressions, which we still had factoring, but in addition to factoring we could cancel out vertically but also diagonally. So if I look at these different trinomials, so the top left one I'll try to factor. So I see that's x squared plus x minus 20. Now it's going to be a pretty easy one to factor because again the first term is 1, it's just 1x squared. So 1 times negative 20 is negative 20. So I'm trying to figure out two numbers that multiply to negative 20 and add to 1. Well, that would be pretty simple. That's 5 and negative 4. 5 times negative 4 is negative 20. 5 plus negative 4 is 1. So this is going to factor as x plus 5 and x minus 4. So if I go over to my expression, I will now replace that top with x plus 5, x minus 4, that top left, over 2 times 10x, which really doesn't factor. And then the bottom we have x squared plus 5x, which both terms have an x. There's only 2, so I can take a GCF out of x. So I take an x out of both, so I'm left with an x in the first and just a 5 in the second. So I factored all the numerators and all denominators that I could. And now I can cancel out anything vertically or diagonally. So I see these x plus 5s diagonally, which I can get rid of. I can also get rid of these x's. But I also have a 10 and a 2. Well, 2 will divide into 10 and leave me with a 5. So if you see what we have left, we have a x minus 4, and we have a 5. I'm just going to write the 5 first. You certainly could write it second, but just, by make it look a little nicer, I put the 5 first. Okay, let's look at number 6, which is going to be a division problem. Now, division will work very similar to multiplication, except for when we have division, we will flip it and make it into multiplication. So I can rewrite this as 3x minus 6 over x squared minus 9x plus 20 times x squared plus 7x plus 12 all over x squared plus x minus 6. So now I'll factor each of the tops and bottoms. So for the first one, 3x minus 6, I can just take out a 3. For the bottom right, I'm thinking of two numbers that multiply to 20 and add to negative 9. So that's x minus 5, x minus 4. And since we've done so much factoring, I'm going to kind of just go through these a little quicker. So the top right one is going to be two numbers that multiply to 12, add to 7. That'll be x plus 4, x plus 3. In the bottom right, two numbers that multiply to negative 6, add to 1 will be positive 3 minus 2. So now I can cancel out what's the same. So I see the x plus 3's will cancel, the x minus 2's will cancel, and I believe that's all. So our final answer, I'll kind of write it over here, is going to be a 3 which is left, an x plus 4 which is left, and on the bottom an x minus 5 and an x minus 4. Okay, problem 7 looks a little different, but it is, again, it's a fraction, but this big fraction bar really just means division. So really rewriting this, I can write this as x plus 4 over x divided by 7 over x minus 4. So again, now this will work similar to the one before. Well, we could take x plus 4 over x and will turn into multiplication by the reciprocal. So there's really nothing that factors and nothing really that cancels out, so I can just multiply straight across. So this will be x plus 4, x minus 4 over 7x. Alright, let's look at our next one, which we start to do addition. Now if you remember, for addition we have to have the same denominator by getting common denominators. So our denominators here are x minus 3 and x plus 3, which are not the same. So our LCD is just going to be simply both of those, x minus 3, x plus 3. So what I want to do is I want to take both of these and I want to rewrite them with this new denominator, which would be x minus 3, x plus 3. So, what I have in the first one, I already have an x minus 3. Or I don't have an x plus 3. So what I'll do is I'll add an x plus 3 on the top as well. On the second one, I have an x minus 4 on top. On the bottom, I had an x plus 3, but not an x minus 3, so I have to put an x minus 3 there. So we're just putting whatever's missing on the top. So now our common denominator will be x minus 3, x plus 3. And now the top will have two foils. So I'll FOIL the first one. So it's going to be x squared plus 3x plus 2x plus 6. And it's a plus in this case, so no big deal. If it's a minus, you might have to distribute a minus, but in this case not. So when I FOIL this one, x squared minus 3x minus 4x minus 12. So now I'll just put all the terms together. So I have 2x squareds. I have 3, 5x's. 5 minus 3 is 2. 2 minus 4 is negative 2x. And then I have 6 minus 12, which is going to be negative 6. Over x plus 3, x minus 3. Now I can try to factor the top and see if it'll reduce. They both are even, which that could possibly factor. You could take a 2 out, x squared minus x minus 6, or minus 3. But there are no numbers that multiply to negative 3 add to 1, so this would just be our sum. So the key thing to adding and subtracting is just making sure the bottoms are the same, and then adding the tops after you put whatever is missing on the bottom onto each top.
Alright, so for problem 9, we're going to solve the rational equation. The first thing that I noticed is that I don't have an LCD, so I need to figure that out. And I can see right here that I'm going to need a factor. So I'm going to do that first. So I'm going to write that over here. X squared minus 6x plus 8. And when I multiply 8 to the imaginary 1 that's here, I get 8. And I ask myself what multiplies to 8 but adds to a negative 6. Well, that would be negative 4 and negative 2. So when I make my factor box, I'll put my x squared here, I'll put my 8 here, and then that negative 4 and negative 2 go in these boxes with an x on the back. And then a negative 4 comes out on this row, row. An x comes out on this row, an x can come out on this column, and a negative 2 can come out on that column. So it's x minus 2x minus 4. So if I rewrote the problem, I've got x over x minus 2, just rewriting this problem right here, plus 1 over x minus 4 is equal to 2 over, and I factor that now, x minus 4, x minus 2. Okay, so I can tell now that my LCD is x minus 4, x minus 2, based on all of these down here. And so when I look at that first fraction, it's missing an x minus 4. And so for the x on the top, I'm going to multiply it by what it's missing, the x minus 4. For this fraction, this x minus 4 is missing the x minus 2 from the LCD. So I'm going to take the 1 up here and multiply the 1 by the missing piece of the LCD, the x minus 2. And then lastly, this is not missing anything right here. It's got the full LCD, so I don't need to multiply that 2 by anything. It just stays a 2. Now, this is actually my new problem, because this whole thing, it just kind of canceled out. And everything on the top canceled out, but we kept whatever was not included in the LCD on the bottoms of the fractions, and they put them on the top. We were multiplying them. So now we're multiplying this x, we're distributing it. I can tell that becomes an x squared, and that becomes a negative 4x. And then I can distribute the 1, which just becomes plus x minus 2 equals 2. There's an imaginary 1 in front of that x. And so I noticed these are actually common denominators, or not common denominators, like terms. And so now I've got x squared, and a negative 4x plus x is a negative 3x. And then that minus 2 comes down, that other 2 comes down. I'm going to subtract the 2 on one side, subtract the 2 from its like term on the other side, and now I have x squared minus 3x minus 4. And I have 0 over here. And I can tell that this is factorable. So let me bring it over here. X squared minus 3x minus 4 is 0. Well, to factor it, negative 4 times 1 is a negative 4. Oops. And I asked myself, what multiplies to a negative 4 and adds to a negative 3? Well, that would just be negative 4 and 1, because that would add to a negative 3. And so if I did my factor box, I'll try to do a tiny one. I had an x squared, and I had the negative 4, and I have the negative 4 that I just figured out, and the 1 that I just figured out. It would end up factoring. This would be a negative 4, this would be a 1, this would be an x and an x. It add factors to an x minus 4, x plus 1. Now, I'm not done yet. Last step here is I need to take that x minus 4 and equal it to 0, and the x plus 1 and equal it to 0. When I add the 4 on each side, and when I subtract the 1 on each side, those become my answers for x. X is 4, x is negative 1. I could stop there, but you will notice, though, that if I take that x equals 4 and I plug it back in up here, I want to make sure from my original problem that it doesn't zero out any of the denominators. So when I plug it in at the x minus 2 up here, well, 4 minus 2 is 2, so that doesn't zero out, but 4 minus 4 does zero out. So x cannot equal 4. The 1, though, 1 minus 2 is negative 1, and 1 minus 4 is negative 3. And we know that when we factor that last one out, it is also an x minus 4 and an x minus 2, and that the 1 worked with those, or even the negative 1, whatever it was. So this is our answer. All right, for number 10, I'll try to move it so I'll have enough room to go over it. For number 10, we're just going to start looking at our denominators, and we've got an x minus 2, we've got an x minus 2. So if you notice, there's nothing that needs to be factored. So I'm going to shoot right to figuring out the LCD. And hopefully you've recognized that the LCD is x x minus 2. Because this has an x minus 2, this has an x, but this has both. And so that's all we need for all of them, is the x minus 2. So now I'm going to take the 10 and ask myself, is it missing anything for its denominator? And it is not, because it has the LCD fully on the bottom, so I don't need to multiply 10 by anything. And then 4 is missing the x minus 2 on the bottom, so I'm going to multiply that 4 by x minus 2. And then 5 is missing the x on the bottom, so I'm going to multiply the 5 by x, because it's missing the x on the bottom here. Alright, pretty simple. All you do is distribute that 4 into that x minus 2, and you get 10 plus 4x minus 8 equals 5x. I notice that 10 and a negative 8 are like terms, so I'm going to make that 4x plus 2. So that 10 minus 8 is 2. Bring down my 5x. Last step, subtract out the 4x because it's like terms with the 5x on each side. That cancels. I have a 2 left. And then 5x minus 4x is just 1x, or just x. So x is 2. Again, we can't stop. We have to make sure we check it. So looking at the original problem up here, you can see that 2 minus 2 on at least one of these right here is going to make a 0. So 2 is not a solution, but it's the only solution we got. So basically the answer to our problem is no solution. Alright, for this problem, we're trying to figure out where the rational equation has a vertical asymptote. So I can immediately see that this is factorable here on the bottom. So I'm going to factor that, and I should know that 21 times 1 is 21, and what multiplies to 21 and gets to 10? Well, that's 7 and 3. And so if I did my factoring box, I would get x squared and 21. And I would get 7x and 3x, and I would end up getting x and 7 and x and 3. So basically that factors to y equals x plus 3 all over my x plus 7, x plus 3, what I just factored. And you'll notice that the x plus 3's cancel. And if you remember from our notes, that's where we find our hole in our graph. And so remember, to find your hole, you take what cancels, which is that x plus 3 that canceled, you set it equal to 0, and you solve by subtracting 3 on each side. X is negative 3. That's where we're going to find a hole on our graph. Now, to find, the problem was asking for vertical asymptote. Well, we still have an x plus 7 on the bottom of our fraction. We're going to set that x plus 7 equal to 0. And when we solve that, we get x equals negative 7. And that is what our vertical asymptote is in our graph. Vertical asymptote at x is negative 7. And you can see that here on this graph.
So if we look at our graph of the function we just found the asymptote for, you can see that this does have a vertical asymptote at x equal negative 7, because the graph is broken apart at x equal negative 7. So the Desmos graph verifies what we saw. So our last problem talks about finding the slant asymptote, or the horizontal asymptote for a rational function. Now we said that you only have a slant or oblique or horizontal asymptote if the degrees are not bigger on the bottom. If the degree is bigger on the bottom, then it's automatically 0. This one's not. We have one on the top and one on the bottom. So when I long divide, you can see that I took the first term on the inside and divided it by the first term on the outside. 6x over 4x. The x's cancel. 6 over 4 reduces to 3 halves. So we have a horizontal asymptote at 3 halves. So we said this graph, here's the graph of the rational function. So we said there is a horizontal asymptote at y equals 3 over 2, which is 1.5. So if I look for 1.5 on here, if I put a horizontal line, we can see that the graph does get very close to it. You can see here it's getting very close to it, and here it's getting very close to it. Okay. So that is all for our review for Module 5 test. Go ahead and ask us any questions and prepare yourself for your test.